Find f of g of x and the domain of the composite function. All right, so we have f of x and we have g of x. We want to combine them or make a composition of them. And the way we're going to do that is basically start with the first function in the statement, f of g of x. That'll be the f function. Leave a space wherever there are any x's, right? So I'll put a space, -1, space, -3. And in the space, you plug in the inside function, which in this case is g. So it'll be x plus 6 over 2x minus 5 in that first space, and the same thing in the second space, x plus 6, 2x minus 5. All right, from there, you've actually technically done the composition. It's just a matter of doing the algebra to clean it up a little bit, right? We want to make sure that we write it in the simplest terms we can. Okay, so probably the best thing to do here is to multiply everything in the fraction, right? This is a compound fraction or a complex fraction. It's basically got a lot going on in it. In both the numerator and the denominator, there's two terms, right? So essentially what we want to do then is to multiply all the terms in the fraction by 2x minus 5. Why 2x minus 5? Because that's the denominator of the fraction that's inside of the fraction, right? In other words, we're taking the LCD for all the terms we have that make up that complex fraction, and we're multiplying the numerator and the denominator by that. Now, if we multiply everything by that quantity, what's going to happen? Let's take a look. We'll have a 2x minus 5 here, a 2x minus 5 here, 1 down here, and 1 over here. Again, every term gets a 2x minus 5 multiplied by it, right? What's nice about this one here is that it'll cancel out with the denominator, and you don't have much left, just a 2 times x plus 6 left over there. Here you'll have the 2x minus 5 cancel out as well. So for the rest of it, we just need to perform the arithmetic. So it'll be 2 times x plus 6 left standing in the first term, then minus 1 times 2x minus 5 in the second term, fraction bar. Then we'll have just x plus 6 left over in the first term in the denominator, and then minus 3 times 2x minus 5 for the last term. If we actually just go ahead and perform that arithmetic, then we'll have 2x, correct? And 2 times 6, which is 12, minus 2x, plus 5, that's the numerator, and then the denominator will be x plus 6, minus 6x, plus 15. And then from there, you just need to combine like terms. So look at the two x's here, they'll cancel out, it gives you 17. And in the denominator, you basically have negative 5x, after combining the x's, and then 6 plus 15 gives you 21. Okay, very good. That is your final function, and that is your f of g of x function. And then the only thing we're left to do in this video or this problem is to actually say what the domain is. So remember, when you're thinking about the domain, you want to think about the final function and then the function that went inside, right? So the final function is a fraction, so we need to be worried about a 0 in the denominator, so we need to make sure that negative 5x plus 21 is not equal to 0, right? So in order to do that, I need to subtract 21 from both sides, right? And I'll have negative 5x, therefore, is not equal to negative 21. If I divide both sides by that negative 5, I'll end up with x is not equal to 21 over 5, right? Remember, the negatives will cancel out because there's two of them. So what we're going to say basically is that this leads to the idea that the domain for the final function is from negative infinity up to 21/5, right? Round parentheses, pick up again at 21/5, and continue on to positive infinity. This means all the numbers are okay except for 21 over 5. Now remember, that was the final function. We still need to consider the inside function. The inside function in this particular case was that g function, right? Because we did f of g of x. And the g function also had a restriction. The denominator there, 2x minus 5, cannot be 0 either. So if we solve that, we'll end up with 2x cannot be equal to 5. And then if you divide by 2, you end up with the idea that x cannot be equal to 5/2. So it means we need to throw 5/2 out of there as well. So we need to make sure that 5/2 is not included in our domain. So basically we're saying all real numbers except for 21/5 and 5/2. Okay, so let's put that all in there together then. So this, remember, is not our domain. We have to actually make it even more restricted, right? So we'll say from negative infinity now up to 5/2. 5 halves, by the way, is 2.5, right? And 21 over 5 is 4 1/5, or 4.2. So basically the 5 halves comes first on the number line. That's what I'm getting at, right? So union from 5 halves, so we'll pick up again at 5 halves, not including it though. Go up to the 21/5, right? Close parenthesis, union, and then we do 21/5 all the way to positive infinity. So this is the domain of the function. That's the domain of the composite function. So basically it's all real numbers except for 5 halves and 21/5.